Thanks, everyone. I hope everyone is doing well. And I want to thank Zaloni to giving me this opportunity to talk. Brief introduction. My name is Shashi Rena. I'm the partner solution architect at AWS. So let's dive into the agenda for the day. So we'll kind of talk about data ops. I know Ben covered in a lot of great details and with good content, but we'll kind of talk about that also again. We'll talk about this supply chain pipeline, and we'll talk about the AWS ecosystem and how it kind of enables data ops and supports, and then we kind of zoom in to one particular service called Lake Formation, which is a newer service which was released recently, and how it kind of enables the whole data ops narrative on AWS platform. So, what is data ops? People, it's a new term. People don't know much. I know people know about DevOps a lot, but this is a newer term. So, what is going on in past few years that the data and analytics teams are evolving. They are becoming more diverse and complex, and they're being challenged by within the teams within the company. They're being challenged to scale their work and deliver data to support a lot of range of consumers and use cases. So you have your BI users, you have your data scientists, and you have everyone in between, right? So there's a lot of pressure to deliver faster and maintain high quality products. So data ops techniques can address the challenges through a more agile and a collaborative and change-friendly approach to building and managing the data pipelines. Data ops actually incorporates the agile methods to shorten those cycle time for analytics. One thing which kind of differentiates it from the DevOps, which is more common, for most of the people, is that while DevOps is an IT function, data ops is not an IT function; it's an operational function. But it does use similar principles to DevOps to kind of make the quality, to enable collaboration, to enable orchestration, security, and access. It's not tied to a particular technology or a framework, but it's more on the process side, on the operation side. Zaloni, who's an AWS partner, have a platform which kind of Ben talked about. It provides like such tools to the end customers that helps with the data ops. So let's talk about the data ops principle here. Like these are some of the principles which kind of map to our Amazon's leadership principles. We'll start with the customer obsession, which is something which we value a lot in Amazon. So customer obsession is basically to provide access to data insights to the customer across the entire spectrum. Right? And this spectrum could be like live data, which could be minutes old, to like weeks old data, right? And the value of data with time changes, so we have to keep that in mind while we serve the customer. So that's a key aspect. Now, the data pipeline will evolve with customer needs. Sources will change within the same source. The format may change. So we need to accommodate all those things that deliver results. And that's something which Ben also going to mention around his presentation. We talked about flexible pipelines or reusable pipeline, right? The next thing is learn to be curious, right? That's another leadership principle, which we value a lot. So what it means is that the data ops process should include a feedback loop that helps to improve the process. And this is something which DevOps also incorporates, and this is something which DataOps is also doing it, which helps to improve the processes from end to end. Disposable environments. This is a big one because that drives a lot of this cost saving for the customers. Basically, you can spin up the environments when you need them. You can just turn them down when you don't need them. You can do this through your infrastructure automation. You can do this from by separating your storage and compute. So you can basically still like save a lot of those compute costs basically while you're spinning those environments down. The next piece is to simplifying the process. We always need to look into aspects of how do we simplify a process for an architecture. We know that the security and complexity, is not a good thing because it increases the barrier for the user. So keeping the process simple helps in also in the security of the process. So that's something which is key area also in data ops. The other aspect, which kind of is something which we talk a lot, is like how analytics is like manufacturing, right? Why is it so? Because analytic is kind of basically we are putting data to be consumed, which is very similar to what manufacturing does, right? When manufacturing, we create a product which is being consumed by the consumers. So data pipelines are basically very much like those lean manufacturing lines, and teams are basically those those um, those factories producing those data sets for consumption. That's why it is very important to achieve efficiencies in the process or converting data to insights as the core principle of data ops. So we kind of talk about these all data principles, and and based on what Ben talked, in the previous conversation, you will kind of start to notice that there's a pattern here, right? So what he talked kind of maps to these principles, like that's what's basically what his arena framework is doing, is kind of aligning with these principles. As an example, like Zaloni arena framework provides a workflow which kind of creates sort of data pipelines, and those pipelines can be reused. It goes back to the point I made where the source and format can change, right? The other thing which I want to highlight is that how Arena kind of develops the metadata and it maintains the lineage. So it kind of goes back like to the whole feedback to improve data and processes, something we talked also in the past. So it's kind of, now you can kind of understand a little better the patterns of data ops and how Saloni is kind of taking those principles and creating like a product along that for customers to use. So if you look at this mission statement, the two words which I really want to highlight and emphasize are securely and democratize, basically. So it's not about giving access to the users only. It's also about giving the access with the right amount of security and governance. And that's the key. If you look at like a operating model right now, what I want to show you is like how the depending on the maturity of the enterprise, the systems or the current set of systems could be like in a very island like fashion, right? You have your CRP system, your logistics, your sales, you have all the accounting system just lying there as an island. But the key takeaway is that the goal is not to unite them. The goal is to link them and kind of get the coordination between them. And that's where what we kind of depict here in the future state. And if you know about the Linux platform, they use like modding techniques to find like duplicate records, and they create like a complete single record as a golden record. So this helps, to provide a single comprehensive picture of customers from all different systems. You can have your voting system, you can have your partner system, you can have all the systems, and this helps them to create like golden record, and it helps like user to have a 360-degree view. Some of the architecture design principles, which are on the slide, like they're the important ones, especially the first one, right? If I want to consume a data, and the data could be in a data warehouse or a database, and I go to the owner of that asset or resource and ask them to for permission, and I also ask them, okay, by the way, you'll have to do these changes on your side so I can consume it. Like most likelihood is that they will not give me that permission or work with me on that, right? So we have to minimize disruption on the data side. So that's the key. So whatever we design, whatever we implement, we have to make sure that the disruption is not there for the producers. Then we have to focus on those 80% of use cases that can be satisfied by the configuration. That does not mean that you should not be doing custom coding. Of course, if there is a need, then absolutely do it. But do understand that there are challenges around maintaining this code, and also if you are kind of migrating in some of the systems, it could be a challenging to kind of migrate the code. So keep that in mind while planning your operations aspect. Also, like not look at the tool. Like the tendency is to look at the shiny tool, latest tool in the market and buy it, and then figure out how to use it. Right? It should be other way around. We should look at what we need from a functionality perspective, what our needs are, and then find the right tool for that. And this is kind of the philosophy out at AWS too. Like if you look at our ecosystem of databases and analytic tools, there are a lot of them, right? But each tool has a reason to be there in the toolbox. And it's important to understand that. But some people may think that, oh, they all are related. That's not the case, because each tool has a specific need, be it like a DynamoDB or they have the special use cases which we have to understand before we use them. A good example I give people is that, if I want to cut my hair, right, I would use a scissor. Now I could use that same scissor to cut the grass on the lawn. I can possibly do that. I can just take the scissor and start cutting my lawn, but it may take me days, depending on the size of the lawn, to get it completely done, right? So that's where we have to see like what is a tool which is right for that process. In this case, I will use lawnmower for the lawn, but I can use a scissor for my hair, right? And I will not swap it, God forbid. So those are the key aspect of choosing the right tooling. Now also you need to understand that after we use the right tool, we are using based on our existing conditions, right? Now tomorrow the thing can change, the customer need can change, the use case could change. So we have to keep it, the data to be decoupled so that a new tool can come in the future and just work just seamlessly with data, right? So that's the thing. And also, while we use all these tools, we can make sure that, or we try to make sure that data is not moving. Right? Data stays there, and we just put the tools where the data is. And this kind of will help, like in future scalability and other aspects. And also, if you are in the cloud, like movement of data means cost, right? So keep those things in mind also when you design your architecture. This is like a conceptual architecture. This is a typical data architecture. Ben also had something similar on this presentation. The left side, you have all the producers, and then you have your different stages. You have your ingest stage where you get the data from the producers. You either archive it, roll your, or you can start tracking the lineage as you can go through the pipeline. Then you can go to the processing stage, right? There, that's where basically the 80% of the work is done for any analytics project or data science project. So this in this stage you are doing your cleaning, you're getting the dirty data out of the system, you're focusing on data quality, you're fixing the data errors, then you're gonna aggregating the data based on your business summaries, you're doing your ETL. This is like a major chunk of most of the projects. Then you come to the enriching part, right? This is where you start adding value, which is not inherently in the data. So you will apply your advanced statistics tools or your data science techniques to kind of put that data, the delta data into the origin data set. That's how you enrich the data. Now you do while you're doing all these things, you are still like securing your data, you're cataloging your data, you're profiling your data. So at the end result, you have a data which is secure, which is cataloged, which is profiled, and it's kind of open, right? And now you can serve different users through different consuming services or through different dashboards. Typically, the users, which are on the other side of the consumption aspect is the AI users, your data scientist user, right? Now let's talk the logical. So we talked about the conceptual architecture. Now we kind of start looking at the logical architecture, which essentially means that we are creating a data board to get the data into this data lake, right? And then we have a data warehouse. We are building a data warehouse from that. Now, data lake doesn't replace data warehouse. Some people think that data lake is a replacement for data warehouse, but generally, in general, it's not. So, data warehouse, as you see in the diagram, actually feeds the data lake, and you use data lake essentially as your basis to meet your analytic needs. You can even use create data mart data warehouse, which can again feed the data lake. So now you're moving everything to data lake, and data lake is serving as the platform for your team and your tool needs. Now, while you're doing this, you are cataloging the data, and then you can expose different kind of patterns out there. You can expose pattern like giving reporting as a service to the user or analytics as a service to user, right? You can even let your end customers or users to bring their own tools to the data, right? People love tools like Tableau or they love tools like MicroStrategy. So now they can use the tools and come to your data lake and just start processing and consuming the data. Let's talk about the AWS portfolio around this narrative we are talking about. This is again by any way is not a complete picture or complete list of services, but the relevant services which kind of map to the topic we are discussing on data ops. So the bottom side of the deck, it kind of the slide, it contains data migration service as the first entry. So DMS essentially is a very powerful way for customers to take their on-prem assets and put in the cloud. They can do like homogeneous data migration or heterogeneous data migration. And I'll explain what it means. So homogeneous means that you could have an Oracle on-prem database and move to your RDS Oracle database on cloud. That's same, right? Or you could take that Oracle database on-prem or move to your Aurora on the cloud. That's your heterogeneous. So you can do both in both scenarios. Now, if you want to just move plain data from your data center, or your enterprise data center, your private data center to cloud, you could use something like Snowball for petabytes of data, right? Now, if you have a lot more data than petabytes, then you can use Snow Mobile, which basically can transfer around exabyte of data, but you'll need a 45 feet long container for that, which is kind of exciting. Then you have your Kinesis Stream and Firehose to ingest your streaming and live data. Now, if you go one level up at the data lake level, we have S3, which is essentially the central you know storage for data lake. Then there's Lake Formation Service, which is newer service which provides the governance, access control around data lake. We'll talk about that a little in details as we move forward in presentation. And there's Q, which is your dual purpose ETL and data catalog. When you move up a little bit, you will see your analytics suite, which you have your Redshift, which is your for structured data using SQL. You have your EMR Hadoop ecosystem. You have Athena, which you can enable Hadoop query, and then you have your Elasticsearch for your operational and your analytics. So these are your analytics suite, which we have to support these operations. On databases, we have, as I talked about in previous slide, that it's purpose-fit database, right? So Aurora is a super fast data for your SQL, and it is like 10% cost of the commercial database out there. You can use DynamoDB, which is a key value pair for your web-facing application, which needs like really fast speeds. And then you can use your Neptune, which is really catching up if you want to like unearth the relationship within the data. SQL is not the right engine for that. So you use something like Neptune or graphics libraries in your EMR. And then, yeah, so then you have QuickSight and SageMaker, which is at the top of the stack, which you can essentially use for visualization. And SageMaker is your one-stop shop for training data, developing models, deploying models. So let's define what data lake is, right? So data lake is a centralized repository that allows you to store both structured and unstructured data, and that's the key: the structure and unstructured part. That's what data lake does enables for you. Um, how does it different than data warehouse? Over a period of time, they have implementation of data warehouse, which is around the structured data. With the social media exposure, with the device exposure, and there's so much data coming, sensors, logs data, operation data. So what data like does is it provides you space to store that rich and non-rich data, and you can scale it out to exabytes. And then you can add different tools, as we talked about. You can have your machine learning tools, you can have analytics tools, talk to that data and start processing it. And you can do this without moving data from point A to point B. I think which is very powerful. And while you're doing this, you don't have to pay a lot of storage like you would pay on on-prem systems. You don't have to do when you use S3 as a central database, data lake. Now, what data lake is like openness, right? It kind of opens up the whole ecosystem of data for your company, for your user. So you can essentially take different snapshot data from your different sources, like a warehouse, right, in the space, and put it into your data lake. And then you can create like a fact data set for Redshift to kind of consume. If you want to create like find the relationship between data, use cases for that essentially are your fraud detection, right? you want to see like what are the relationship between different entities. You can use something like Neptune, right? Or you can just use Apache MXNet. If you want to do like a lot of machine learning on the data, so you can kind of have your purpose-fit data sets, right, for your use cases, and you can have like and as the data is refreshed in your source, you can refresh these data sets as the data keep on coming, right? So what it enables is that it goes back to the data principle, where now you have multiple tools looking at the data in different ways, right? And you're only paying for the data processing as you need it, right? So that basically this is how it ties back to the data ops principles. So they are data lake challenges we're trying to solve, like especially around putting the data security, access control, and enabling cataloging and auditing, which takes a lot of time. So typically, what we heard from the customers, the customers is that hey, we like the data lake, ecosystem, but it takes a long time for us to put the operationalize database, data lake into execution. So then we thought, okay, we need something to solve this. We came up with the lake formation service, which actually helps to create data lakes and kind of reduces the time from data to insights from months to like days. And the way it does is that typically you have your your like multiple steps when you create data. Like you have your ingestion where you would take the data, you put into your storage, S3 in this case, then you do your preparation of data, then you review data, then you secure it, and then you start analyzing it with your tools, right? This is like how it typically goes. So what lake formation does is that it kind of gives you like out of box tools to kind of expedite this process. So it gives you like blueprints, which are your templates to hook up with your source systems to get the data out. It also gives you enhanced data catalog where you can put your metadata tags. It provides you ML transformation, which essentially helps you solving the datafication issues, which is very common. Like you could have my name spelled like in three different ways. It could be SHASHI, one. It could be SASHI. Sometimes people put E in that. So I could be I could author in like four different roles when the same person, right? So if you use traditional SQL to kind of fix those things, like it will take a lot of time, especially when you talk about like scale. So what ML Transform does is it can do that for you pretty fast, and then it provides you with with a security and governance layer over top of that. So how does so you just take your existing S3 bucket, or you can create a new S3 bucket, you register that information, and then that's it. And then the data is secured to the lake function security model. And you have direct access to data with the security umbrella, and there's a lock. This is your data. You can take it out from data lake when you want. This is how typically it works. So you have your footprints. You can get data from sources like Aurora, RDS, and Kinesis, CloudTrail. You can do a one single shot, or you can do incremental load into your data lake. Once it goes there, you can use your blueprints. What you do with your blueprint is that you point it to a source. In this case, it could be a RDS. You tell the location on the destination side on your S3 bucket, and then you get the frequency. That's all you do. And the blueprint will kind of discover the source table. It will get the schema, it will do partition, it will do everything and get the data into the data lake. So now you have compressed that ingestion time, by fairly a good factor of magnitude. And it provides you a little console where you can do like text-based search. You can add attributes to the columns, to the table. You can put sensitivity levels. So I can define that column as PI information, and accordingly, kind of the rules in place for that. Um, and that's the key thing. So lake formation is not a next new service. It's built on top of the catalog, but it provides you a net new security model. So it gives you an enhanced layer now, which was not there before. It also helps you to have a single dashboard for your auditing, for your activities, and you can put your alerts and alarms with these console events, and put into your service pipelines, your troubleshooting pipelines. And this is where the most of the value of that low provision services. So it gives you a centralized security model, right? So you define this user provision once in a central fashion, and once when the user is coming from different services, be Athena or Redshift, to consume the data, the the same security model will apply to all the services. So you don't have to go now and set up a different policy for Athena or a Redshift. So and if you want to roll it back, you just do it at the lake formation security model level, and all the services will be now not able to be inaccessible for the user now. So the centralized model is the net new for the lake formation, which provides a lot of value to the user. This is just one example of how it kind of works. Like before information, if you want to provide permission to a file, you have to give at object level. So you have to put your IMRP policies around that. But here now with lake formation, you can take the same file and take like the 10 columns are in the file. You can take those 10 columns and say, okay, I want 5 columns, access for the user one, and I want rest 5 columns for user two. So you can break it down to that level now, which is very powerful. And with this, I will end the conversation, this presentation, and I will take the questions from the audience.
Thank you, Shashi. You can just leave your screen right here, and I do have a couple of questions to ask you.
Sure.
The first one from your session is, can lake formation support cross-account pattern?
So yes, it can. This was in fact released recently. So what it does is it kind of enables like a pattern where a vendor or partner can create like a data lake, and then give the cross-account permission to a VPC, which is a part of the account for a customer who can access that data lake to the tools with the same security model. So, I mean, the details are actually in our documentation on the website. So, I will encourage people to go and take a look at that. But in principle, yes, we can do that.
Okay, and we have time for one more question. Is AWS planning to open up lake formation blueprint ecosystem so partners can publish their own templates?
So, yeah, in the fullness of time, like I can see that happening. I mean, this is one of the requests which we see a lot from customers. This, along with the row level access and security, is something we are being asked a lot. I can see that happening in the future.
That's great. Thank you very much.